Okay, so if you take a look at the learning goal at the top, what we're trying to do in this video is to make sure that you understand how to multiply rational expressions. Okay, so we have our rubric down at the bottom. What your goal is by the time you watch the video and then try out the problems in class and the checkpoint problems, you should be over here and be able to do the problems without asking any questions, because that's what you would do on a test. Okay, so here's some regular fraction solving. We want to go back and remember how to just multiply fractions. Okay, so if it says 2/3 times 9/10, the way that we multiply fractions is we say just multiply across the top. We'd say 2 times 9 is 18. We'd say 3 times 10 across the bottom gives me 30. And then I need to look at this and see if it's reducible at all. Right? And in this case, it looks like the top and the bottom have a 6 in them. So I'm going to say this is the same as 6 times 3. And the bottom also has a 6 in it. It's the same as 6 times 5. And then I can cancel out the 6's. And it looks like my final answer is 3/5. Right? So that's how we multiplied normal fractions. And so we're trying to do the same thing when we do our rational expressions, except we're going to be doing them with polynomials. Right? So let's look at one more example of multiplying normal fractions, because I want to show you one little trick that we're going to end up using. If I multiplied 5 times 14, I'm going to get 70. 70 is a bigger number. Right? So in this case, if you notice, what happens is I can actually look for factors along the bottom and on the top that have something in common. So if you notice, this 2 doesn't have anything in common with 5, the one it shares the fraction with, but it does have something in common with the 2. I can take 14 and I could say that's the same as 7 times 2. Right? And then I can cancel out the 2 down here with just the 2 part of 14. And I can do the same thing with the other 2. If you notice, 35 is the same as 7 times 5. And then I can cancel out the 5 on the bottom and the 5 on the top. Right? So we have this idea that if you find a factor anywhere along the numerator and a factor anywhere along the denominator that match, you can cancel 1 on the bottom with 1 on the top. And in this particular problem, the 7 and the 7 also cancel, and we get one great big 1 over 1. Right? Because the 7's cancel as well. The only thing that's left over on top and bottom is 1. Okay, but in other circumstances, there will be things that are left behind, and we'll be able to reduce a little bit more than just to say that this entire thing turns into 1. Okay, so we have two big concepts. Multiply all the way across the numerator, all the way across the denominator, and we also have the ability, before we do any of that multiplying, to simplify the expressions by canceling any factors that match on the top and the bottom. Okay, so let's take a look at multiplying. So we're saying to multiply or divide rational expressions, we are going to factor and look for anything that cancels in the numerator with anything in the denominator. It doesn't even have to be in the same fraction. It could be in two different fractions, and if we can find a match, we can cancel. Multiply straight across the top, straight across the bottom, and I put in parentheses. You can leave that in factored form, so you don't have to FOIL everything back out and multiply it back out and get one polynomial. We can leave it in multiple parts. So here's an example. Okay? So if you notice, in this particular problem, if I were to go through and look for factoring, x plus 4 doesn't factor, 3x doesn't factor, x plus 4 doesn't factor, but 3x plus 21, there's a GCF of 3 in this. So I'm going to turn this into, let's leave the first one by itself. Okay? We didn't change anything in that. But the second one, I can say this is the same as 3 times x plus 7. Okay? Okay, and so now when I look for things that match, factors that are the same on the top and the bottom, I see an x plus 4, that cancels out an x plus 4. And I see a 3 here, which I can cancel with this 3 that I factored out. Because again, can't factor sums or differences, but 3 times x, and this is 3 times x plus 7. So that means that they're both factors. So if I see collect together what I have left on the top and what I have left on the bottom, now multiplying across, I can say, well, it looks like I just have the x plus 7 on the top, and I just have the x on the bottom. Okay, so I would say this is my final answer. Okay, that's the product of those two expressions. Okay, so let's take a look at another one. Okay, so same thing going on here. I have a lot more that factors though. So let's factor all the parts. X minus 2 does not factor. That's as simple as that gets. It's a linear binomial. The bottom, that looks like a GCF of 2 is involved. So I'm going to say this is 2 times x plus 1. Okay. I'm multiplying that with, again, this top part factors into 4 times x plus 1 with the GCF. And the bottom turns into 4 times x minus 2. Okay, so I have a lot of canceling happening here. All right, I can say 4 cancels with 4, x minus 2 cancels with x minus 2, x plus 1 cancels with x plus 1, And remember, if there's nothing else left on top, we do always have a factor of 1 that multiplies with everything. So it looks like this whole thing, this whole big expression multiplied together is really just 1 over 2. And that would be my final answer. Alright, let's take a look at a couple more. Okay, so your first problem, again, we're starting to get a little bit more different factoring happening. 2x plus 3 does not have any GCF and no other way to factor that, so I'm going to leave that alone. 4x plus 6 does factor. That's 2 times 2x plus 3. There's a GCF in that. Okay. 4x squared minus 36, we can factor a couple different ways. So the first thing I see is there's a 4 involved. So just off to the side, I'm going to say this is the same as 4 times x squared minus 9. And then x squared minus 9 factors again because that can be written as x squared and 3 squared, x squared minus 3 squared, and that's a difference of 2 perfect squares. So I'm going to say this whole expression turns into 4 x plus 3 and x minus 3. Okay, so sometimes you'll have to factor and factor again. All right, and then our last piece, x minus or 3 minus x doesn't factor by itself, but if you notice, I have an x minus 3 right here. And so I can cancel out a 3 minus x if they match, and they're really close. This one has negative 1 in front of the x. This has positive 1 in front of the x. This has a positive 3. This has a negative 3. And we saw this when we were doing simplifying before we started multiplying. We said if you pull out a negative symbol, that's the same as switching the signs on the inside. Right? So the negative 1 on the outside, this becomes an x minus 3. Right? So the sign was negative, now it's positive. Sign was positive, now it's negative. If I distribute this back in, I do get negative x and positive 3. And so that's an okay factor. So that we need that in order to get this match here. Our first cancel, x minus 3 and x minus 3. Okay? I see 2x plus 3 and 2x plus 3. And in this case, I see a 2, and one of the 2's in 4 will go away, which means the 2 times 2, I'll just get rid of one of them. All right, so it looks like the only thing that's left on the top is 2 and x plus 3. So I'll leave that factored, 2 times x plus 3. Okay. And then I'm going to put the negative side. I'm going to say, let's do 2 divided by negative 1. I'll just make this negative right here. So instead of doing over negative 1, I decided to do the division. And I'd say this is my final answer. Okay. I think we have one more to take a look at. Okay, and this one's got a lot more going on. And so we'll go through it step by step. Okay, so again, 3x on the top. That's fine. That's already as simple as it gets. It's linear. Okay, x squared plus 3x minus 4, that is find numbers that multiply to negative 4 and add up to positive 3. Well, that would be x plus 4 and x minus 1. Okay, and then here I have a couple of things happening. I have the 2 that can come out. So again, we'll do this off to the side so we don't have to rewrite the whole problem again. 2 times x squared plus 7x plus 12. Right, that's a GCF. And then x squared plus 7x plus 12 is just like our x squared plus 3x minus 4. Here I can say this is 3 times 4. This is 3 plus 4. This factors into x plus 3 and x plus 4. Okay, so now I can do my canceling. Remember, this is the same thing as being over 1. So let's do some canceling. I see x plus 4, and I see x plus 4. And I'm taking a look, and I don't see anything else. Right? X minus 1 and x plus 3 are not matches. 2 doesn't have anything on the bottom. 3 doesn't have anything on the bottom. Regular old x doesn't have anything on the bottom. So that's it. So when I put all this together, here's what I get. 3x times 2, I can multiply across the top and get a 6x times x plus 3. Again, you don't have to FOIL out the x, distribute out the 6x into. You can just leave it in its factored form. And then on the bottom of this, I'm going to say the x minus 1 is the only thing that's left. Or x minus 1 times 1 is just x minus 1. And I would say this is my final answer. Okay, so we ended up with a lot of parts that did not cancel in this one, but we did cancel a couple parts and then multiplied across the numerator and multiplied across the denominator. And that's your summary. Every single one of these problems. Factor, cancel what cancels, multiply across the numerator, and multiply across the denominator.